Welcome back to Learn as you explore for another mBot2 tutorial. In the previous video, we implemented our very first Python program for the mBot2. We started with a small project in which the distance measurements are printed on the CyberPi display. We uploaded and tested this on the robot. In today's tutorial, by popular demand, we're going to implement line following in Python. We will use the proportional control project that we previously implemented using block program as a reference and implement it in Python. Before we dive in, here's a quick way to support my work. If you're planning to get an mBot2, you can use my Amazon affiliate link in the description. It won't cost you extra, but as an Amazon associate, I earn from qualifying purchases. Or if you just want to say thanks, there's a buy me a coffee link down in the description too. All right, let's jump in. In the first 10 minutes of the advanced line follower tutorial, I explained the concepts that are needed to understand the equations that we will use today. So if you haven't watched that yet, be sure to go watch the first 10 minutes of that tutorial first before proceeding. The link to that video is in the description. Let's first take a look at our block program that we built in our proportional control line follower video. This program says that when button B is pressed, we initialize our variables and then loop until button A is pressed. Pressing button A will stop both the wheels and exit the program. Within the loop, we get the deviation value reported by the quad RGB sensor and then calculate the left and right power based on this deviation value. We then command these power values to the wheel motors of the robot. Let's convert this block program to Python code. To do this conversion, we will need to refer to the API docs like we did in our previous video. I introduced these two API docs in the previous video. In this tutorial, in addition to these two, we're going to refer to a third API doc as well. This is the mBot2 Shield Python API docs page. This page contains APIs that relate to motion commands like drive forward, turn, etc. I'll add links to these web pages in the description. I highly recommend bookmarking these in your browser so that you can access them easily since we will be using them often. Let's now look at the APIs that are needed for this project. To do that, let's look at our block program and think of the block categories we used when building it. The when button B pressed was from the events block category. The was button A pressed was from the CyberPi sensing category. The quad RGB sensor deviation block was from the quad RGB sensor category. And finally, the encoder motor left and right power blocks, as well as the stop encoder motor blocks, were both from the mBot2 chassis category. Now, you might have noticed that we have not covered all of the blocks here. For example, we have these variable blocks, this repeat until control block, and the green operator blocks. The reason that we're not going to look for APIs for these is because Python by itself allows us to do things like set variables, loop until a condition is met, and perform basic arithmetic operations. So we don't need a specially built API to achieve those functions. This means that we need to find APIs only for the blocks marked in red here. We then have to think about which page we would need to refer to in order to find these APIs. Since the button B press and button A press blocks are buttons on the CyberPi, we can start by looking into the CyberPi Python API docs. Since the quad RGB sensor is a sensor, we can first check the mBuild Python API docs. Since the motion command APIs are likely to be in the mBot2 Shield Python API docs, we will start by looking there for the motor power and stop motors blocks. Now, let's head on over to the documentation pages and find the APIs that we need. We are now in the CyberPi Python API document. If you don't see this outline pane on the right side, you may have to toggle this button to open or close the outline pane. We identified that we need to find two APIs from this CyberPi API doc. First is the when button B pressed event block. In our last video, we used the isPress event decorator that we can find under events by scrolling in the outline pane. So if you go to events and scroll down a bit, we see this isPress decorator, which is the one that we used for button B press. We'll use the same API this time as well. Next, we need to find the sensing API for button A pressed. Since we're going to be checking for button A press within the loop, we cannot use a decorator like we did for button B. Let's look for sensing because this is a sensing API. In the outline, we see sensing right here. Click on that, and the very first API here is cyberpi.controller.isPress, and the argument or the parameter that it takes also supports button A, which is exactly what we need. So we'll use this for checking if button A is pressed within the loop. Now we're in the mBuild API page. We're looking for the quad RGB sensor deviation API. Scrolling through the outline, we see under sensors that there's the quad RGB sensor section. Let's click on that. The very first API gives us the line status, which is not really what we're looking for. We want to get the deviation value. So keep scrolling and let's look at the next one. This API says get offset track, and let's read its description. It says obtains how much quad RGB sensor deviates from the line to be followed, and it returns an integer ranging from -100 to +100. So this API is the one that we need for our project here. Finally, for the APIs related to motion commands, we're now at the mBot2 Shield API page. Here, let's click on Motion under the mBot2 Shield section. First, we're looking for an API that takes two values, one for the left wheel power and the second for the right wheel power. So let's look for an API that supports providing power values to it. We see a forward API, which doesn't look like what we need. Then there's a backward, which is also not what we need. Turn left, turn right, straight, turn. And here, this is something that's interesting to us. So we see a drive power, and it does take in two power values for EM1 and EM2. EM1 is the left wheel, whereas EM2 is the right wheel by default. So this is the exact API that we want to use for our project. The last API that we're looking for is an API to stop both the wheel motors of the mBot2. Continuing to scroll down, we see the mBot2.emStop API. This stops the specified motor, and we have the option to stop all motors, which fits our requirement. Coming back to our presentation now, we can clean this up a little bit. Since we're only interested in identifying the APIs, let's clean up everything else. I'm going to now split the two mBot blocks into separate items here. Now let's record the APIs that we need to use for each of these blocks as we had identified from the API documentation pages. Awesome! Now that we have all the APIs identified here, we're ready to start programming. First, open your mBlock desktop application. Now let's give our project a name. I'm going to call it Tutorial 12 Python Proportional Line Follower. Add the mBot2 device by clicking on Add and then selecting mBot2 and click OK. Switch to Python mode by clicking on Python here. We have our block program on the right side for reference. Let's add some comments now to form the structure of our program. First, we need to import the required modules. Then, we're going to use the button B pressed decorator and define a function that replicates the steps in the block program. The steps in the block program are: first, we will initialize the base power and KP variables. We will then loop until button A is pressed, and within the loop, we will get the deviation from the quad RGB sensor. Once we have the deviation value, we will calculate the left power and right power values. Then we will command the left and right power to the motors. Finally, outside the loop, we will stop the motors before quitting the program. Now that we have these comments, you can clearly see the structure of the code and what needs to be done. For the imports, we need to import the CyberPi module, the mBuild module, as well as the mBot2 module. The decorator that we chose to use from the API docs was at cyberpi.event.isPress, and the button we're looking for is button B. Now we can define the function. Let's call our function onButtonBPress. Within our function, we want to first initialize base power to the value of 30 and kp to the value of 0.3. Then we'll start the loop. We need to loop until button A is pressed. We can use a while loop here. We need to be careful about setting the condition for the while loop. We want to keep looping as long as button A is not pressed. So the condition should be while not cyberpi.controller.isPress, and the button we're looking for is A. Within the loop, we'll first get the deviation value. So let's initialize a new variable called deviation and set it to the value returned by the API mBuild.quadRGBSensor.get offset track, and the index is 1 because we have only one quad RGB sensor. Now we can calculate left power as base power minus kp times deviation. This is from our equations for proportional control. We can then calculate right power as minus 1 times base power plus kp times deviation. Now let's command the power values to the motors. We will use the mBot2 API, mBot2.drivePower, and pass in the left power as the first argument and the right power as the second argument. Finally, outside the loop, we'll command a stop to both the motors. We'll do this using the mBot2.em_stop and pass all to stop all motors. And that's it. We're now done with the proportional control line follower project in Python. So let's save the code for this project. We can now upload and test it out on the robot. To upload, make sure you have the robot powered on and connected to your computer. Then switch the mode to upload and click connect. Select the COM port for your robot and select connect. Once it's connected, you can go ahead and click upload code and wait for the code to be uploaded to the mBot2. Now that we have the code uploaded, let's test it out on the robot. Let's test our proportional control program using the make block line follower sheet. We'll press button B to start the program, and we see that the robot follows the line, making fine adjustments as needed to stay on track. We can stop the program by pressing button A. Congrats! You're doing great with our transition to Python programming for the mBot2 robot. You probably noticed this, but it is worth reflecting. In my opinion, it was easier to implement this project in Python as compared to block programming. Do you feel the same way, or do you think it was easier in block programming to implement this proportional control line follower? Let me know in the comments below. If you found value in this video, hit the like button and subscribe to learn as you explore for more mBot2 tutorials. Here are some of my other videos that you may find helpful. Happy programming, and I'll see you in the next one.